All right, today is going to be our most intensive lesson in this entire unit. So this one's going to take us a while. It's going to go through a lot of stuff. Just giving you a heads up. You're going to have a lot of notes and things. Take your time to go through this. Ask questions where needed so you can really make sure you understand these three main things that we're going to learn today. So today we're going to calculate, interpret, and compare measures of variation in a data set. Write that down along with today's date and page number. And before moving on to the APK, take a deep breath and then get started. All right, find the mean and median of each of these data sets. This should be pretty easy. Come back when you're done. Here are the answers you should have gotten for the warm-up. Pretty straightforward, 17 and 15, and 11 and 11. All right, now that we're thinking about math, we are ready to move on. Let's get started with this pretty intensive but very knowledgeable lesson. All right, so we have a teacher. Her name's Miss Snow, and she asks all her students how many pets they have. Here are the responses. One said 9, one said none, one said 4, a couple said 1, a couple said 2, one said 3, and one said 5. Now, Miss Snow then is going to take this information and she's going to display it. We're going to display it in a way that we haven't displayed yet. And it's using a box and whisker plot. So what is that? Well, you're going to have to write it down in your notes. A box and whisker plot, or box plot, is a data display that shows how data is distributed by using median, quartiles, least value, and greatest value. Now, we mentioned this word quartiles in here. Quartiles are 3 values, one of which is the median, so the middle number, and that divides the data set into fourths. So you're going to find the quartiles of every 25% of the data. So make sure you have these two definitions down before we move on. Now, how can you use a box and whisker plot? Well, they can be used to show how values in a data set are distributed. You're basically looking at the variation you have or the spread of the values of some data. So make sure you have that down for variation or variability. It's the spread of the values of the data. So how far is it spread out? Now, when you look at the entire spread out, you can break it down into several different areas called the interquartile range, the IQRs. And that's the difference between the first and third quartiles. And it is a measure of the spread of the middle 50% of the data too. So a small quartile range means that the data in the middle of the set is very close to the value. It means it's very accurate. A lot of people are real close in their answers. Large interquartile ranges means the data is very spread out. And we're going to work through how to find that stuff today in this lesson. Before moving on, make sure you have these two definitions down. All right, we're going to go through making a box and whisker. You're going to follow along with me on these steps. Now, if at any time you want to go and watch the example videos, for example, one from the textbook or on the Moodle where I have them, it might be helpful for you to watch someone else go through them as well. Just letting you know. Okay, so the average number of hours that several students watch television in a day is given to us here. So we're going to take this data and we're going to make a box and whisker plot. We're going to take all this information, meow, and put it into a setup. So I have all the steps labeled for you. All you need to do is write these down so you don't lose track of them. Step 1, we're going to take the order of the data from least to greatest. So we have 1, 1, 2, 2, 2, 2, 2, 3, and 5. Those are the amount of hours that are given that the students watch television. I probably would be close to that 5 if I was lucky. Now, step 2 is we got to find the least and greatest values. So I marked those in green. Least is 1, and greatest is 5. That's good to know. Now in step 2, we also got to find the median. So what's the middle number? And because we have an odd number of students that gave info, it's easy to find the middle, which is 2. Now, working from the least value up to that median, or just before the median, find the first quartile, and then after the median to the greatest value, find the third quartile. You're just finding the average with the quartiles. Okay, so first and third quartiles are the 1/4 average and the 3/4 average. So when we add up the least value of 1, 1, 2, and 2, that adds up to 6. Divide that 4 ways, you get 1.5. After the median, we have a 2, 2, 3, and 5. If we add those up, that's 5, 6, 7, 8, 9, 10, 11, 12. Divide the 12 4 different ways, and you get 2.5. Sorry, I didn't mean to say mean. I meant to say median. So break them down after the median. So once you got the median, kind of block it off. Now you're looking at the median on one side of it and the median on the other. That's 1.5 and 2.5. Sorry if I said mean, median. Too many words. The middle. We're looking for the middle. Okay? So step 2 again is find the largest and smallest value. Find the middle of all the values. Then find the middle of the left, middle to the right. Okay. Once we have that, let me get rid of that. Then what you're going to do is you're going to draw a number line. And I usually go from the smallest number to the greatest number. And then you're going to plot a point above each of the boxes for the 5 values. Let me get rid of this. Okay. So if we draw the box, or we draw the number line, we're going to go from 0 to 6, looks like, because we were just under that. And once you draw the box, you're going to draw, you're going to draw a box through the first and third quartiles. So first we put down the median, then we put the median of the first section, median of the last section. Last thing you're going to do is put 2 dots of the least and the greatest value, and then just fill in that box around the first quartile, third quartile, and right down the middle. So now what we're doing is we're looking at the data and we're seeing where it sits. And we can see that all the numbers are pretty close together and way to the bottom. And then we have a number way out at the end on the far right. We know that as an outlier. So we can see how an outlier is affected in these. Again, if you want to watch me go through this again, you certainly can, or watch example 1 video on Moodle for how to have this done. All right, now that you've watched me, maybe twice, maybe you've watched the example, it's time for you to be able to do a box and whisker plot of your own. So what you're going to do is you're going to do these 2. And what I want to do is I'm going to help you go through one more, which is the top one, and then you're all going to do the bottom one on your own. So again, what we need to do is we need to put all the numbers in order. If you want to try these both on your own, pause the video now. So it goes 80, 84, 85, 86, let's make sure I haven't missed any, 87, and 90 for this problem. Okay, now that we have that, the next step of finding out the box and whisker plot, or making the box and whisker plot, is to find the least value, I'll underline that in green, and the greatest value, which is 90. Now we got to find the median. So if we break down to the middle, 80 and 90 are gone, 84 and 87 are gone. Between 85 and 86 is where we'll find the median, which is 85.5. Okay? Now we got to find the median of the left of the center and right of the center. So the median for the first quartile is 84, and the median for the third quartile is 87. Once we got that, now we have to just make our box and whisker plot. So we're going to start out by putting down a number line. And we'll start down here at 80. And go to 81, 82, 83, 84, 85, 86, 87, 88, 89, make it a little longer, 90. All right, now we just got to plot the numbers that we had to find. The least value is 80. Greatest value is 90. At 85.5 is where we find the median. 87 is where we find the third interquartile. And 84 is the first interquartile. I like to draw a line straight through them right away. And then I make my box and whisker all completed. So this is what it should look like if you did it right. All right, now everyone is on their own to do the next one. Come back when you are finished. All right, so in number 7, your box and whisker plot is really spread out. The box is spread out. The whiskers are kind of small. When you have smaller numbers like this, only looking at numbers from 1 to 10, sometimes your numbers are going to be real spread out because you don't have much of a difference in value. And you had a lot of people giving different ratings, all the way as low as 2 and as high as 10. That's a big range. So that's what you should have got. If yours looks pretty close to mine, because my drawing is not perfect, give yourself a nice pat on the back. If you're stuck on these and struggling, make sure you come to me so I can help you kind of make these box and whiskers. It takes practice with these. Once you get them down, they're pretty easy to do. It's putting all the numbers in order, finding the median of the left and the median of the right, and then putting them on a number line. Now, interquartile range sounds real difficult, but it's actually a pretty easy thing to figure out. So you're going to want to write these notes down in your notebook, but listen to me go through it first before you go and write anything down. So let's say we had to find the interquartile range for a set of data. And the data was, as you can see there, 87, 71, 72, 73, 84, 92, 73. Here are the steps. The first step is order your data from least to greatest. So we have 71 to 82. Then find the median in the quartiles. We just did that. The middle number is 73, and the middle number to the left of 73 is 72, and the middle number to the right of 73 is 87. So then all you got to do is you got to subtract the lowest interquartile range from the highest interquartile range. So in this case, it's 87 and 72. When you subtract those, you get 15. So the interquartile range is 15. It's basically saying between the smallest median and the largest median, this is where most of your data is going to be. So what's the range of that normal data there, which is 15? Kind of helps us to figure out where most of the data is going to be. It kind of gets rid of the outliers and looks at a true data range of what you got. All right, so I have a lot of problems up here, and you don't need to do the bottom part. These are only if you want to do extra. I want you to do these. So I'll help you with number 2. Like I said, the first step is put them in order. 3, 4, looks like we got another 4, and we got 2 5s, a 6, and a 7. Okay. Now we just got to find the interquartile ranges. First thing I do is find the center. 3 and 7 gone, 4 and 6 gone. Here's our center. And all the numbers to the left of the center gives us a 4. And the middle number to the right of the center is 6. So all you have to do here is do 6 minus 4. And the IQR is 2. Okay? Go ahead and work on 3, 4, and 5. Come back when you're done. Again, if you want to do 8, 9, 10, 11, you're on your own to do that if you'd like. And I can show you if you got the right answers or not. All right, so after doing the work for 3, 4, and 5, you should have got 8, 3.5, and 2. Now, if you did 8, 9, 10, 11, just to help you, 8 was 3, 9 was 8, 10, you had to have a little more work, I think, with this one, 3, and then this one didn't come out perfect. It came out to be 13.5. So those are the answers you should have gotten if you did those. If you want to do those and do a little reverse practice, you can go back and try to see how you get that answer. All right, here is our last example for this lesson. Nice long lesson, but it's got some good stuff to it. Another measure that we can use is called mean absolute deviation. Mean meaning average, absolute deviation. This is the mean about the data values. So this is the average about the data values that differs. And it's our way of trying to see what we get. So we're not going to go through this problem. We're going to go through this problem. And I want you to follow the steps that I have on the board and work with me on this so that you can see how to do this properly. So our scenario here that we're looking at is that a scientist is studying the temperature variation or the temperature change, and she determines that the temperature at noon on 4 days would be the following: 75, 82, 78, and 67. So what is the mean absolute deviation of the temperatures? First step, find the mean. So add them all up, divide by 4, and we find that the average temperature at noon on those 4 days is 75.5. Okay? So from here then, you have to find the distance on a number line that each value is from the mean. So what does that mean? Well, that means you have to do a little subtraction. Okay? If we looked at the first temperature, which is 75, we know that 75 is a half a degree away from the mean or the average of 75.5. So to solve these, you just take each of the numbers and you subtract it from the average. So for the first one, the first number is this, so it's 75.5 minus 75. The second number you'll see is 82, so you just do 82 minus 75.5, and you'll see that it's 6.5 units away. Then the next number is 78. Change colors again. And you're going to do 78 minus 75.5. And you can see what I'm doing is making sure I'm doing a larger number minus a smaller number, because it's just finding the absolute value of something. You don't need to know if it's positive or negative. So 78 minus 75.5 is 2.5. And finally, the last number is 67. So here we're going to do 75.5 minus 67, and that's 8.5 units away. So the absolute deviation of those are shown there. Okay, so that's the first step, is you find those averages. Make sure you have this all written down before I click to the next slide. Now, what do you do with the number 0.5, 6.5, 2.5, and 8.5? The last step is you find the average of those. So you add up 0.5, 6.5, 2.5, 8.5, and then you divide by the 4 temperatures, and you find it to be 4.5. And again, this is temperatures, so that'd be degrees Fahrenheit. So what does this actually tell us? It says the mean absolute deviation of the temperatures is 4.5 degrees. So why is that important? Well, it's important to know that on average, during these days, the temperature can change by about 4.5 degrees at noon each day. It's always good to know that range, because it kind of tells you where the corrections or changes might occur within that time period or those temperatures. So have this down before moving on. All right, so we're going to do number 6 together, and then 12 and 13 you're going to do on your own. Now, if you want to just do these all on your own, pause the video now. All right, so for number 6, there's 7 animal shelters in a local area. The number of cats in each of those shelters is 4, 6, 3, 7, 4, 5, and 20. 20 is an outlier there. We got to find the mean absolute deviation for the number of cats in shelters to the nearest tenth. So the first thing we have to do is we have to find the mean. So if I add them all up, I get 20 plus 25, or 20 plus 5 is 25. 25 plus 4 is 29. 29 plus 7, what in the world happened there? 29 plus 7 is 36. 36 plus 3 is 39. 39 plus 6 is 45. Oops. And then 45 plus 4 is 49. I should have that right. And then when you divide 49 by 1, 2, 3, 4, 5, 6, 7, I'm going to get 7. So now that is our average or our mean. And now, as we saw in the example I did with you, you just got to find how far away each of these numbers are from 7. Well, 20 minus 7 is going to give you 13. 5 minus 7, or 7 minus 5, is going to give you 2. 7 minus 4 is going to give you 3. 7 minus 7 is going to give you a 0. 7 minus 3 is also 4 away. 7 minus 6 is 1 away. And 7 minus 4 is 3 away. So now that I got all these, I'm going to add these up. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So I get 26. And I'm going to divide it by 1, 2, 3, 4, 5, 6, still 7. And 7 goes into 26. 26, it's going to go in 3.7 times. So the absolute mean deviation, or the variation of change there for these animal shelters, is 3.7 from the median, or the mean, or the average. Okay, 3.7. So really, you find the average, then you find the average of the distance away from each other. So I want you to go do number 12 and 13 now on your own. Okay, 12. When you take all those numbers and you find the average, and then you subtract the average away for those 5 games, you find out that the average deviation for the number of points for Maggie's first 5 games was 6. A change of 6. Now, the ages and weeks of the 6 infants learned to crawl, the absolute deviation for the age in which these infants learned to crawl, and I rounded to the nearest tenth, was 4.3. 4.3 weeks. Okay? If you got those right, good job. If you didn't, I can help you through it. You just got to come talk to me, or work with someone else if you want. All right, so take a deep breath, because you finally got to the box of thought. So for each of these, go ahead and write them down. Explain what is shown in a box and whisker plot. What are you looking at? And discuss what the mean absolute deviation shows about a set of data. Maybe reverse the video back and look at some of the notes that I had on the board for you. And here's your quiz, 3 questions. Take your time doing these. It says a park ranger measures the thickness of the ice on a lake in 8 different spots on the lake, and that's what he found. Make a box and whisker plot. Find the interquartile range. Remember, that's the 3rd interquartile minus the 1st interquartile. And find the mean absolute deviation of that data.